Okay, let's go ahead and do this last one on page 1 of your Module 3, Lesson 3 notes. Get the top up here so you can see which packet it is. So Module 3, Lesson 3, Student Page A. We're on the very bottom of page 1. So now we're using the triangle as the unit. So this counts as one hole. So we need to know how many holes are in this. So we can take, I know we already did this earlier, and we can see that there are 1, 2, 3, 4, 5, 6 holes in this figure. So this counts as one hole, and they want to know how many holes are in this figure, and there's 6. So we write the number 6. Now we look at the trapezoid, and we see there are 3 triangles in the trapezoid. So if this is one hole, a trapezoid would count as 3 holes. 1, 2, 3. And so that's what our bottom row is looking like so far. So the triangle's a hole. How many triangles are in the diamond? When we draw this line across, we see 1, 2 triangles. So the diamond would represent 2 holes. And last but not least, the diamond itself is 1. So you can see, look how the numbers changed in that first column and in the second column. So these do not represent the same thing. It's all based on the unit. So for instance, when this was the unit, this counted as a whole, but when this was a unit, it was only 1/3 of the whole. So each of these numbers change based on what we pick for the whole. So we have a couple more to practice on page 2. So let's go ahead and turn over to page 2. This might be a place where you want to stop the video and try to practice some of these on your own. So you've seen me do them. I'll give you a hint on this page because the units are such weird figures. My class and I figured out last semester it's much easier if you divide everything into triangles. So take your there's triangles, there's the triangle, there's the triangle, and then do the same thing with all of these. And before you stop the video and try to do some of these on your own, remember this number up here is the numerator. This number down here is the denominator, because this is how many we have. This is how many make a whole. Just like when we have a picture like this, our numerator is always how many we have colored, and the denominator is always how many make a whole. So you're going to use that same philosophy when you do this. How many do I have up here? How many make a whole? So I'll just do the first one. Well, actually, I'll just keep doing them. You can stop the video whenever you want. Try and practice some on your own. So how many triangles do I have? I have 6 over the whole. This is the unit section. How many triangles are here? 6, 7, 8, 9. But do you notice anything about that fraction? It's not simplified, is it? Do you recognize that 3 goes into both of those? So pretty much from here on out for the rest of your life, every single time you write an answer that's a fraction, it needs to be simplified. So they're not going to tell you, hey, don't forget to simplify that. You just have to know. So 6 divided by 3 is 2. 9 divided by 3 is 3. So this is 2/3 of that. You can see there's 2/3 of it and there's some piece left over. So numerator, 1, 2, 3. Denominator, we already said, is 9. 6 plus 3. So this is the numerator, this is the denominator. Numerator, denominator, numerator, so on. So again, do you notice that that one can be simplified? What goes into 3 and 9? 3, right? So we divide both of these by 3. And we get the new fraction is 1/3. 3 divided by 3 is 1. 9 divided by 3 is 3. So see, once you get the trick with the triangles, this is pretty easy. But trying to figure out just by looking, oh my gosh. So here we have 2 in the numerator, 9 in the denominator. And the good news is that doesn't simplify. Yay! Because nothing goes into both 2 and 9. Here we have 1 in the numerator, 9 in the denominator. So that signifies 1/9 of the unit. So this is 1. This is 1/9 of that because there's 9 triangles. Okay, so go ahead and do the other ones. I'll go ahead and go over them now, but if you want to stop the video and try them on your own, that's great. So numerator, 6. Denominator, 1, 2, 3, 4, 5. And we'll practice changing this into a mixed number. I'm not really sure which way they want it, but 5 goes into 6 once. Subtract, 1's left over, so it's 1 1/5. So we can just not circle either one, just write both answers. So whenever I'm not sure which way they want it, I just write both. And so then I have all my bases covered. Okay, this one, numerator 3, denominator 5. So 3 triangles over 5 triangles. Same thing here, numerator 2 over the denominator 5 triangles. And last but not least, 1 triangles in the numerator, 5 in the denominator. So what that's saying is this triangle is 1/5 of this picture, and you can see it's made up of 5 triangles, so it's 1 out of the 5. Okay, last one, 1, 2, 3, 4. It looks like our denominator is going to be 4. So this is 6 triangles over 4 triangles. Remember, the number up above is your numerator. This is your denominator. So this would be 6 over 4. But there's 2 things wrong with that. We should write it as a mixed number, and it can be simplified. So let's simplify first. What goes into both 6 and 4? What's their common factor? 2, right? So divide by 2, divide by 2. So we get 3 over 2. So that could be the answer they want, or we can do division. 2 goes into 3 once. 1 times 2 is 2, and we get 1 and 1/2. So one of those 2 answers is what they want, either 1 1/2 or 3/2. Okay, next we have numerator 3, denominator 4. So that trapezoid would be 3/4 of this picture, and you can see it's 3 out of 4 triangles. Then we have numerator 2 over denominator 4, so that would be 2/4. 2's common to both of those, so that gives us 1/2. And last but not least, 1 triangle's in the numerator, 4 triangles are in the denominator. So that triangle is 1/4 of the picture, which you can see it's 1 out of 4 triangles. So interesting little activity there. Okay, so let's go ahead and move on to the extension. I'm going to warn you ahead of time. Some of these are going to make your head ache. You have to think kind of differently than what you're used to. So this first one is very tricky for students because when I tell you to write 7/4, you divide everything up and make 4 intervals and do 7 copies of 1/4. Well, this isn't saying make 7/4. This is saying that this segment is 7/4. So that means 0's here and 7/4 is here. So that means this is 7 copies of 1/4 in here. So, and that's what a lot of students do wrong. They want to make this 1 and then go past it, or they want to put 7/4 here, but it's saying this length right here is 7/4. So we start at 0, we end at 7/4. So we need to make 7 copies of 1/4 in there. So 1, 2, 3, 4, 5. So 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4. So let's go ahead and write those in. So 1/4 is here, 2/4 is here, 3/4, 4/4, 5/4, 6/4, and that would make this last one 7/4 as they said it was. Okay, so there's one more question. Describe how you can determine a length of 1. So what's a length of 1? Which of these numbers represents 1? This, right? So a length of 1 would be from here to here. So we could write, let's just draw an arrow, 4/4 equals 1. So 4 copies of 1/4 is 1. So that one's kind of hard to describe. You kind of really just have to draw a picture to show that. So if somebody wanted to know how long 1 was, you would just draw that and show from 0 to 4/4 is 1. So we could write 1 equals 4 copies of 1/4, which is 4/4. That's a pretty good description, right? Okay, I think we might have time for one more, so let's turn to the last page of this packet. This one's almost identical, so this is a really good one to practice on. See if you got it. So this one says segment CD has a length of 4/7. So that means 0 is here and 4/7 is here. So that means this is 4 copies of 1/7. So we're not going to divide it into 7 like we would when this is 0 and this is 1. We need 4 copies in there. So we can do this. So 1 copy of a 7th, another copy of a 7th, and another copy of a 7th. So this is 4 copies of 1/7. 1/7 plus 1/7 plus 1/7 plus 1/7. So I don't even read the rest of the problem right away when I read that, then I move on. Describe how you can